Now the next reaction that we'll see is the reduction reaction, where hydrogen will react with metal oxides. Now when we look at the reactivity series, now any metal which is found below hydrogen, these are considered to be less reactive than hydrogen, and hydrogen can reduce these metal oxides. So for example, hydrogen will be able to reduce copper oxide, hydrogen will be able to reduce mercury oxide, hydrogen will be able to reduce silver oxide, hydrogen will be able to reduce gold oxide. So when the metal oxide will be reduced, so it's going to give you the metal. So let's see. So hydrogen can take oxygen from a metallic oxide to produce metal and water. The reaction occurs for oxides of metal found below hydrogen in the reactivity series, so only for these. So loss of oxygen is called reduction, so you'll have a reduction reaction that is produced. Now here there is a mistake, so I want you to just cross this out. So we're going to do the reaction for copper 2 oxide reacting with hydrogen, because lead is above hydrogen, so lead oxide cannot be reduced by hydrogen. So copper oxide reacting with hydrogen, hydrogen will be able to reduce copper oxide, giving copper, and then the oxygen here and the hydrogen, so oxygen and hydrogen, they will form water. So it's going to form water here. So the balanced chemical reaction will be copper oxide plus hydrogen gas, giving copper and water. And this is already balanced. Now the setup for this reaction is given here. So hydrogen is going to be blown into the reaction setup over here through this delivery tube, as you can see here. And then you have a U tube which contains fused calcium chloride. Now fused calcium chloride, this is a drying agent. Drying agent means that it's going to withdraw any moisture from the gas that you are blowing in. So it's going to ensure that you have a dry gas passing and that there is no water that you're actually driving into the reaction. So fused calcium chloride is a drying agent. Other drying agents that can be used include calcium oxide, which is quicklime, or you can use concentrated sulfuric acid. So here you have the metal oxide, you have a source of heat. So we're heating the metal oxide with hydrogen. So you have dry hydrogen that goes in here. And this is going to react. And normally you should see droplets of vapor depositing on the glassware here. This is due to the formation of H2O, and then you're going to have the pure metal that is going to stay in the crucible over here, and here you have unreacted hydrogen gas that is going to catch fire. Now this reaction is not going to occur with oxides of metal that are above hydrogen in the reactivity series. So these metals here, these metal oxides will not react with hydrogen. Now we saw the position of carbon as well in the reactivity series. Now similarly, carbon is going to be able to reduce metal oxides of metals that are found below carbon in the reactivity series. So from this, we can come to the next reduction reaction, where we see that carbon can take oxygen from the oxides of metal that are below carbon in the reactivity series. So for example, copper oxide, so copper is below carbon in the reactivity series. Therefore, carbon can reduce copper oxide to copper metal. So you will have the equation giving copper plus carbon dioxide. And here you will need to balance the equation, put a 2 here and a 2 here, right? So here you're going to get the metal and then you're going to get carbon dioxide. Well, here you get the metal and then you get water. So hydrogen produces metal and water. Carbon will produce metal plus carbon dioxide. However, we'll find that carbon cannot reduce oxides of metals that are found above carbon in the reactivity series. So you cannot have carbon reacting with potassium oxide, sodium oxide, calcium oxide, magnesium oxide, or aluminium oxide given here.